Worksheet number 4C, page 18, question number 4. Okay, complete the table. So the first number is 0, then 1, 4, 9, 16. So the first number is 0 square. Then we have 1 square, then 2 square, 3 square, 4 square. So the sixth number will be 5 square, which is 25. Next we have 4, then 5, 6, 7, 8. Then the next number will be 9. And usually in questions like this, the final row is usually a combination of the previous row. So we can't really find a link between -4, -4, then -2, then 2, then 8, other than the fact that we're getting this -4 by by subtracting these two. 0 minus 4 is -4. Then 1 minus 5 is -4. Then 4 minus 6 is -2. Then 9 minus 7 is 2. Then 16 minus 8 is 8. And then 25 minus 9 is 16. So 16 is the answer. Complete the table. We've done that. Part B. Find an expression in terms of find an expression for the nth term for sequence A. So this is simply the n square sequence, but n square sequence starts from 1, then 4, then 9. We have an extra number added here, so the nth term will not be n square but n minus 1 whole square. So n minus 1 whole square. We've discussed this in the very first lesson of this topic. Okay. Part 2. Find the nth term for sequence B. So sequence B is simply 4, then 5, then 6, then 7, then 8, and 9. So this is first level common difference. The formula for that is A plus D n minus 1. So 4 plus common difference is 1, n minus 1. So open brackets, we get n 4 plus n minus 1. So we get n plus 3, which is the answer for part B2. This is n plus 3. Alright. Part C, find the value of n when the nth term of sequence A is 576. So the nth term is given. Part C is n minus 1 whole square is equals to 576. Find the value of n. Take under root of 576. That will be 24, and then add 1 to it. So this becomes n minus 1 is equals to 24 and n is equals to 25, which is the answer for part C. Part D. Find an expression for the nth term of sequence C. So we got C by subtracting these two. So the nth term for sequence A is we're doing D1. N minus 1 whole square, and we need to subtract n plus 3 from it. We have to give the answer in the simplified most form. So this becomes A square minus 2AB plus B square minus n minus 3, which gives us n square minus 3n minus 2, which is the answer for D1. Part 2, find the value of the 30th term of the sequence C. So just substitute 30 instead of this n. So for D2, we'll simply, instead of n, we'll substitute 30. 30 square minus 3 times 30 minus 2, which gives us 808. Answer for D2. Question number 5, part A. Complete the table for pattern 5. So we have 6, then we have 9. So we're adding 3, then we're adding 3 again to get 12 plus 3. And so the final number will be 15 plus 3, which is 18. Total number of mats, it's 6, then plus 4, 10, then plus 5 15, then plus 6 21, then plus 7 will give us 28. Part B, express as expression in terms of n the number of gray mats in pattern n. So we need the nth term for this row. So that will be, part B will be a plus d n minus 1. A is the first term, plus d is the common difference, times n minus 1. So this becomes 3n plus 3. Part C, macro makes a pattern with 24 gray mats. Find the total number of mats in this pattern. So macro makes a pattern with 24 gray mats. So 24, after 18 we'll get 18, 19, 20, 21 gray mats, and then we'll get 24 gray mats. So they're saying that macro makes a pattern with 24 gray mats. Find the total number of mats in this pattern. So we need to find this value. So this will be 28 plus 8, which is 36, and then 36 plus 9 will be 45. So 45 is the answer for part C. Part D, macro needs a total of 6 mats to make the first pattern. He needs a total of 16 mats to make the first 2 patterns. He needs a total of 1 over 6 n cube plus a n square plus b n mats to make the first n patterns. Find the values of a and b. So for this, all you need to do is make 2 simultaneous equations. We know that when n here will be equals to 1, our value will be 6, and when this n will be equals to 2, our value should be 16. So substituting n is equals to 1, here we get 1 over 6 plus 2 square is 4, 4a plus 2b is equals to 6 plus, no, we were first discussing the when n is equals to 1. So when n is equals to 1, this equation becomes 1 over 6 plus a plus b is equals to 6 mats. And when n is equals to 2, this becomes n cube, which is 2 cube over 6. 2 cube over 6 is 4 over 3. 4 over 3 plus a times 2 square is 4a plus b times n is b times 2, 2b is equals to 16. Now you have 2 equations, solve them simultaneously to get the answer. Let's multiply the first equation with minus 2. So we'll get minus 1 over 3 minus 2a minus 2b is equals to minus 12. Then we'll write the same equation again, 4 over 3 plus 4a plus 2b is equals to 16. Add all of these to eliminate 2b. So minus 1 over 3 plus 4 over 3 is simply 3 over 3, which is 1. Then we have plus 2a is equals to 4. So a is equals to 3 over 2. Substitute it back here or anywhere. So I'll substitute it back to the first equation. So we get 1 over 6 plus 3 over 2 plus b is equals to 6. When you'll rearrange and simplify it, you will get 13 over 3. Question number 6, part A. The nth term of a sequence is 8n minus 3. Write down the first 2 terms of this sequence. So for that, first substitute n is equals to 1, which will make this n minus 3, which is 5. Then substitute n is equals to 2, which will make this 16 minus 3, which is 13. This is the answer for part 1. Part 2 show that 203 is not a term of the sequence. So for that, what you'll do is write the formula 8n minus 3 equated to 203. When you'll make n the subject, you'll notice you'll get 25.75 and not an integer value. 25.75 can't be a number of term. We can have the 25th term and then the 26th term. We can't have a decimal value. So that is why, since this is not an integer, so number 203 is not part of this sequence. Part B, find the nth term of these sequence. So we're doing B1, 13, 19, 25, 31. What is happening? 4 is being added, then 6 is being added. No, sorry. 6 is being added, then again 6 is being added, then again 6 is being added. So this is first level common difference. The nth term will be 6n, and right now my first term is 6, because when I substitute n is equals to 1, I'm getting 6, but the actual nth first term is 13, so I need to add 7 to it. So this is the nth term for B1. For B2, let me clear the screen. For B2 we have 4, then we have 8, then we have 14, then we have 22. The difference here is 4, the difference here is 6, the difference here is 8, and each intermediate difference is 2 and 2. So this is a quadratic sequence, and the nth term will be an square plus bn plus c. A is this value divided by 2, so a is simply 1n square. So we write the original sequence again, and we subtract n square from it. So we subtract 1 here, subtract 4, subtract 6, 3 square is 9, and subtract 16. We get 3, 4, 5, 6. And the nth term for this is first level common difference, so the nth term is 1n, and right now my first term is 1, but the first term needs to be 3, so I add 2 to it. So the nth term for part B2 is 1n square plus n plus 2. 1n square plus n plus 2. Okay. Part C, dash, then 20, then 50, then again dash. The second term of the sequence is 20 and the third term is 50. The rule of finding the next term of this sequence is subtract y and then multiply by 5. So to get to the next term, we have to subtract y from 20 and then multiply it with 5, and this will be equals to 50, and it says find the value of y, so make y the subject. So 50 divided by 5 is 10, and then 20 minus 10 is 10, so y is equals to 10. And also work out the first term of the sequence. So first term, let's say the first term is x, so we need to subtract y from it, minus 10, then multiply 5 with it, and we should get 20. So this will give us 4 plus 10, 14. So 14 is the answer. This says 144, which is wrong. It should be 14. Question number 7. Table shows the first 4 terms in sequence ABCD. Complete the table. So the first row is 16, which is 4 square, then 5 square, then 6 square, then 7 square. So this will be 8 square, 64, and this is the sequence n square, but we have removed 1 square, 2 square, and 3 square from the original sequence because we're directly starting from 4 square. So we've taken away 2 numbers, so the nth term will be n plus 3 whole square, like we've learned in the first lesson. So this will be 64, and just a second. So So this is 64 and this is n plus 3 whole square. Then we have 5, then plus 3 8, plus 3 11, plus 3 14, then plus 3 17. So the nth term will be 3n, and to make this 5, the first term needs to be 5, so I need to add 2 to it. Okay, next I have 11. Now I am getting 11 by subtracting these two. Then I have 17, which I am getting by subtracting these two, and then I am getting 25 by subtracting these two. So to get this value I need to subtract 64 and 17, which is 47, and then for nth term simply subtract the previous two nth terms, minus 3n plus 2. Then we have in the numerator 3 4 5 6, so the next numerator will be 7, and the denominator we have 2 3 4 5, so the next denominator will be 6. For the nth term, this is first level common difference is the numerator, so the numerator will be 1n, and the first needs to be 3, so I need to add 2 to it, and the denominator is also first level common difference, 2 plus 1, then 3 plus 1, then 4 plus 1, so the nth term will be 1n, and the first term here is 2, whereas my first term is 1, so I add n plus 1. So answer is n plus 2 over n plus 1. Question number 8, part A, complete the table. So we have 6, then plus 4 gives us 10, then plus 4 gives us 14, so the next number will be 18, and then 22. And since we're adding 4 in each case, the nth term will be 4n, and right now my first term is 4, but the first term needs to be 6, so add 2 to it. Okay. Part the next row 2, then we're adding 3 to get 5, then we're adding 4 to get we're adding 3 first, then we're adding 5, then we'll add 8, which will give us 18, then we'll add 7, which will give us 17, and then we'll add 9, which will give us 26. So the nth term for this will be, the nth term for 2, 5, 10, 17 is, the first level common difference is 3, 5, 7, the first level difference is this, and then the second level difference is 2. So this is a quadratic sequence, an square plus bn plus c, where a is 2 and we still need to find b and c. So write the original sequence 2, 5, 10, 17, subtract, this a was 1, so this becomes 1n square. Subtract n square from it, so we subtract 1 from here, 4 from here, then 3 square, 9 from here, and then 16 from here. So we're left with 1 in each case. So the sequence, which is 1 1 1 1 1, its nth term will also be 1. So the final nth term becomes n square plus 1. So this will become n square plus 1. Alright, I'm going to clear the screen. This was 18, this was 22, this was 17, 26, and this was 4n plus 2, and this was n square plus 1. Okay. Part B, find the number of crosses in diagram 60. So the formula for number of crosses is 4n plus 2. So instead of n we write 60. So we get 242. For part C, which diagram has 226 squares? So the formula for the number of squares is n square plus 1 equated to 226. Subtract 1 from 226, take under root, and we'll get 15. Okay. Part D, the side of each small square has length 1 centimeter. The number of lines of length 1 centimeter in diagram N is 2n square plus 2n plus q, find the value of q. So when we substitute n is equals to 1 here, we get 2 plus q, and the total number of lines in diagram 1 is 1 2 3 4 5 6 1 2 3 4 5 6 7. So equate this to 7 and q is equals to 3. Question number 9, part A, complete the table. So fill up this row first. So we have 1, then plus 2 will give us 3, then plus 3 will give us 6, then plus 4 will give us 10, and then plus 5 will give us 15. In the next row we have 3 plus 3 6, so we added 3 here, then we add 4. Next we'll add 6 and then 7, so add 6 to 10, 5 to 10 we get 15, and then we add 6 to 15 we get 21. Next we have 8, we add 7 to it to get 15, then we add 9, then we add 11, and then we add 13. So when we add 11 we get 35, and next we add 13 we get 48. 9b, part 1. The number of 1 unit length in diagram n is n square plus 4n plus p. So they've given us the formula for this row. So we know that the first term should be 8, which means when n is equals to 1, the answer should be 8. So b1, I am substituting n is equals to 1 here. So 1 square plus 4 times 1 plus p, and the first term is equals to 8, which will give me p is equals to 3. B, part 2. Calculate the number of 1 unit lengths in diagram 10. So simply change n to 10. Plus p will be 3, and this will give us 143. Part C. The total number of tiles in diagram n is an square plus bn plus 1, and this is the total number of tiles. So they've given us the nth term of this sequence. So this was, we added 3 here, then we added 4, then we added 5, then we added 6, and the second level common difference is 1, which is telling us that the value of a is half. Once we have that, we can tweak the formula. Half n square plus bn plus 1, and when n is equals to 1, the answer should be 3. So when n is equals to 1, the answer should be 3. So half times 1 square plus b times 1 plus 1 should be equals to 3, and b is equals to 3 over 2. Part D. Part of Louvre's museum in Paris is in the shape of a square base pyramid. So there's a square, and then there will be 4 triangles emerging from the 4 sides. Alright, made from glass tiles. Each of the triangular face of the pyramid is represented by diagram 17 in the sequence. So let me read the question again. Square base pyramid made from glass tiles. Each of the triangular faces of pyramid is represented by diagram 17 in the sequence. Calculate the total number of glass tiles on one triangular face of this pyramid. We need total number of tiles on one of the faces, and we know this is the sequence representing the total number of tiles, and we have its nth term as well in part C, which was half n square plus 3 by 2n plus 1. So substitute n is equals to 17 here, and we will get the total number of glass tiles on one rectangular face. N is equals to 17 gives 171 tiles. Substitute n is equals to 17 in this formula, half n square plus 3 over 2n plus 1. And for part 2, it says 11 tiles are removed from one of the triangular faces to create an entrance into the pyramid. Calculate the total number of glass tiles used to construct this pyramid. So one of the triangles has 171 tiles, and we have 4 triangles in the pyramid, but 11 tiles from one pyramid have to be removed. So the answer will be 673. Question number 10. The table shows the first 5 terms of a sequence A, B and C. Part A, complete the table for the 6th term of each sequence. So first we have 3, then 4, then 5, then 6, then 7. So the next term will be 8. Next we have 0, then 1, then 4, then 9, then 16. These are all square numbers. We have 0 square, then 1 square, then 2 square, 3 square, 4 square. So the next term will be 5 square, which will be 25. And next we have minus 3, then again minus 3, minus 1, 3, 9. So like I discussed this before, that usually the row in the last is made from combining these two. So how do we get minus 3? By combining these two. If I do 0 minus 3, I'll get minus 3. If I do 1 minus 4, I'll get minus 3, and so on. So we're subtracting the number in the first row with the number in the second row. So this will be 25 minus 8, which gives us 17. Okay, part B, write down the nth term for sequence A. So this was simply first level common difference. So the nth term will be 1n, and my first term right now is 1, but the original first term is 3, so we add 2 to it. So n plus 2 is the nth term for part B. Part C1, find nth term for sequence B. So this is a square sequence, but it's not just n square, because n square starts with 1, then 4, then 9, and so on. This one is starting from 0, so we have an additional number. When that happens, we've discussed, you have to write n minus 1 whole square. Part 2, find the value of n when the nth term of sequence B is 8281. So all we need to do is equate n minus 1 whole square to 8281. Take under root, I suppose you'll get 92, and then add 1 to it. So you'll get, when you'll take under root, you'll get 91. Add 1 to it, you'll get 92. This is part C. Part D, 1. Find the nth term of sequence C in its simplest form. So this, we were getting this number by subtracting the first number from the second number. So the nth term will be the second row's nth term minus the first row's nth term. Open this will come a square minus 2ab plus b square minus n minus 2. Simplified answer will be this. D2, find the 8th term of the sequence. So in this formula, substitute 8 instead of n. 8 square minus 3 times 8 minus 1, which will give you 39. Part E, the nth term of another sequence is minus half, which means minus 0.5 power n minus 1. So for the first term, instead of n, we'll write 1. So the first term will be minus 0.5 power 0, which will when you'll enter in your calculators will give you 1. Next you'll enter minus 0.5 power 1, because 2 minus 1 will become 1, and the answer will be minus 0.5. Next minus 0.5 square, and similarly minus 0.5 cube, which will give you 0.25, and minus 0.125.